All right, I'm going to try and keep this file size pretty small, so I'm going to talk pretty fast. The purpose of our lab is to be able to predict the range of a projectile with a known horizontal velocity. We're going to use our two-dimensional t-chart in the x and the y to calculate what our initial speed is using the data that we collected in the lab. We're going to manipulate some of our kinematic equations, and we're going to graph, of course. So this is my diagram. I have my 1 meter along the incline, 1 meter along the horizontal, and then my projectile will go here. I included a table and my marble, and I identified some important information. So we use h as our vertical height in our calculation, so I needed to include h on my diagram, and we include r as our, wait, did I say vertical? Our vertical height, and r is our horizontal displacement in our equation. So I need to identify what r is on my diagram. Equipment where you're using a meter stick, marble, stopwatch, carbon paper, lab table, 2 sections of tracks, a box to keep my inclined plane up, and a plumb line, which I explained in the previous video. All right, so we're going to measure the time the marble is in the air. So not from up here all the way down. We are only measuring the time it is in the air, from when it leaves the table to when it reaches the ground. Okay, I put in there, take care to keep your inclined plane and your horizontal track sections steady, because we are going to use this setup again after we make some predictions. So we're going to roll the marble down the track, time how long it's in the air. And the other things we're going to measure is the height of our table and the range of our projectile. All right, so you can read this red part on your own. Our data is, our height of our table is 73 centimeters. The range, I think we said it in the video. I'll have to go back and check. And how long we were in the air. So we did it 4 trials. I'll get the times for you for tomorrow in class, and we'll do the average, and then we'll set up our X and our Y chart for our horizontal launch, right, and some of our equations. So I'm going to give you the extension questions now in the hopes that you will read through them and understand or come to class with questions tomorrow on what we should be doing. And then my graphs. So my graphs in the horizontal, so my displacement in the horizontal, velocity in the horizontal, acceleration in the horizontal, right? It's 0, so I already put that in. Our displacement in the horizontal, our velocity in the horizontal, and our acceleration in the horizontal. We drew these set of graphs in class on Friday, so hopefully you have that handy. And then is part of your extension. Let's see. Our challenge, this is what we're going to do in class tomorrow. After you do some of your calculations, calculate the new range of a marble if you want to launch the marble so that it lands in a can that is 18.5 centimeters tall. So our height is changing, and so our range needs to change as well. So I'd like you to try some calculations to see if you can predict where we need to put the can so that our marble will go into the can. I'll talk more about that in class today. That's it.